to like participate in condensation polymerization. At the same time, monomers have to be arranged in a particular order. This means after the formation of polymerization, like after the condensation polymer has been formed, they needs to be arranged in such a way that they are like in a particular order. Now, why is it that? Because they need to form to form a particular way or order, you can say, in order to this is not a point, so particular order to react with each other, to make usually to make water or HCl. Okay, so for this reason, we usually need to like the monomers need to arrange them in a certain way. So it's still as a product, like it's a byproduct, you can say, like a small eliminated particle. So this small elimination is known as condensation. Okay, since like water vapor, like water is formed, that's why like more often you can say this is known as condensation polymerization. Let's say an example could be okay. Before that, let's come here and do the reverse example, which I said like we should be like doing it. So I will urge you to pause the video and try to see which of the parts you think are repeating units or could be monomers. There could be multiple, like there could be same type of monomers, different type of monomers. Get like try to guess it. Try to pause the video and say, observe it yourself and try to notice which one is like which one could be monomers, like which one could be a substance which will be able to repeat itself. If you couldn't find, let me help you. Over here, let's see. We have what NH, CH2, CH2, NH, isn't it? Now, try to observe like how this structure is plotted here. Try to see that this part sort of stays as a whole, isn't it? And this part stays as a whole. And see the elements after that. We have NH, that means like up until this part, it is alone. Like how did I understand? See this, here we have C, like C double bond O, yeah? We have C double bond O, and beside C double bond O, we have a NH. So beside C double bond O, we have a NH, okay? So that means this is a different part. Now, towards the left of C double bond O, we have NH another. That means there could be another C double bond O there. Like so far from the picture, what we can assume, isn't it? Okay. Now, what about the other part then? NH. See, like there is, this is totally like repeating itself, isn't it? Like if I consider this one, NHCH2, this is also NHCH2. But defining this as a whole is much more relevant, isn't it? Why? Because this itself is alone and this itself is alone. Like they can continuously repeat after, like one after another. They can like follow the same pattern. Like if I follow this one only, then after this one, we should have like this over here. And after this NaCH2, we should have a C double bond O. But that does not follow a order, because there could be situation where there is like NaCH2, and immediately after that we could have like C double bond O. For example, in this case, we have NaCH2, and after that immediately we have C double bond O. But that shouldn't be the case. We should have like just we can have just two elements one after another. Like this is one of the element, like one of the monomer, and this is one of the monomer. Then we would have again that monomer, again another monomer. Like we can have at most two monomers consecutively. Okay, so basically this is one of the monomer, this is another monomer. Don't worry, this is just for like making you familiar with what are actually monomers and how should they look like in like polymerization. And in the next one, let's see, try it yourself. If you couldn't, let's do it together. Here, see which parts could be represented by itself. Let's see, here we have some sort, it will be seen that this is actually what? This is a part of like carboxylic acid. This could be observed, isn't it? This is a part of our carboxylic acid. And this one, it could be a part of an alcohol, isn't it? This could be a part of alcohol. And here, this could be a part of, wait, this is actually more specific. This is a part of carboxylic acid and alcohol. This is the oxygen of carboxylic acid. This is the alcohol. Or we can say this, if possible, there could have been an acyl chloride also, where chlorine disappeared and reacted with this one, forming an ester. And on this side, the similar way, we have a carboxylic acid oxygen and we have this alcohol. So this could be as a whole, like, because these two are the possible linkage to form this bond. Okay. Now you might be saying, okay, is it like it doesn't like go with the addition polymerization? Like, how is that then happening? Look, addition polymerization doesn't require carbon to be in the main chain. Let's see. See here, none of the like characters say that the monomer need to have carbon in the main chain. There could be different like atoms, different elements in the main chain. In this case, the elements were our, let's say, our oxygen. Oxygen was the uh, like the main source of like forming the bond. Okay. And not necessarily here should be the addition polymerization. Why? Because see, here we can't like we don't like, it is observable that actually here no addition polymerization is happening. You will eventually get it, but this is actually a condensation polymerization. Then this is also another condensation polymerization. Go with the flow. The really completely, it's fine if you don't get it right now. Just go with the flow, because these are actually much more like relevant towards O levels. So if you don't have a solid grasp of like polymerization of O levels, I would urge you to try to like go through the polymerization of O levels if possible, if you have like the resources available from the O levels, because that will be much more helpful. Then we have over here what could be a repeating unit. Let's see. We do have NH2 bond here, and we have this benzene. So what makes much more sense is this one could be one such, yeah. This one possibly one such could be. Another such could be, let's say this one. Yeah, because here we have this one such. So that means these two are same. So that's then completely relevant. Anything else we have? Yeah, we have this one. So this one could be another. Is it? Yeah, it is actually. So these are also like these are like possible monomers. Now see in the main chain, what do we have? Carbon in this case. Yeah, we have carbon in this case. So this is actually addition polymerization. Not necessarily addition polymerization going to have like carbon in actually for our purpose, like for our resource, like for our knowledge, it could, because so far I haven't seen much of I haven't actually seen any of the polymer in addition polymerization to be actually part of like the main chain, like without containing the carbon element or the carbon atom in the addition polymerization. So my previous statement that it is not necessary there should be only carbon atom, it might be wrong, because like so far I guess we'll be good to go with only carbon atoms in our main chain, because that's more of our like concern. Now coming back to condensation polymerization, we have so far the characteristics of the condensational polymerization. Let's see a couple of examples. What such could be. So one is nylon. So the nylon which we tend to like use in making strings, making other sort of materials. Okay, so the monomer is basically diamine. Okay, diamine. Now, how does diamine looks like? Diamine eventually basically looks like this. We have like NH2 group. NH2 means what? Amine. So that means two diamines. Diamine. Okay, two amines actually present. So that's why it's known as diamine. Di means two. So basically, any molecule or any substance with NH2 in one side, then it could be CH2, 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 let's say, and NH2. This could be a diamond, or let's say it could be smaller, like much more smaller or much more bigger. Let's say CH2, let's say 6 NH2. This is also a diamine. So any of the molecule having two NH2 group is known as a diamond. Okay. Now, finally, we like example like another final example would be dicarboxylic acid. Let's see. Let's say the second example could be dicarboxylic acid. Dicarboxylic acid. So here we have, let's say, for example, could be COOH, and here we have CH2, 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 COOH. Okay. Let's give another CH2 and CH2. Let's say here we have four, like just simply representing this in this manner. CH2, then COOH, then we have COOH. Like either of them are correct order of writing. So oftentimes you will see in question paper they write in this way, the way shown at the like below the bottom one. Or it could be also simply just CH2 COOH. This is another dicarboxylic acid. Okay, so we should have like some material which has both in both sides sort of the bond is like there, like in both part a functional group is present so that bonds would be formed. Now, possible reaction. Let's see. Like this is another like these two in turn will react with each other. Okay, this is one of the monomer, this is another monomer. They together will react in order to form our condensation polymerization. Let's see. Let's say we have this NH bond and we have CH2 6, we have NH. Okay, plus we have, let's say here we have a carboxylic acid, and let's say we have CH2 4 OH. Okay, now did I do? Yeah, this is the CH2 6. Okay, so now what happens in condensation polymerization? Basically, we have, let's say, n number of such molecules and n number of such molecules. Okay, we have this in n number, and this we have n number of moles. Okay, now when they react, what happens? This hydrogen and this OH group, they tend to react when they tend to form bond to each other. Then we could have like we have, let's say, other carboxylic acid group on the left side and the other carboxylic group on the right side, because we have n number such molecules, isn't it? So that means actually one of the bond here, like one molecule here, one molecule here, then another carboxylic acid on the left, another amine on the right. So in that manner, actually they are like situated, or they are positioned. So on the right, on the left side, this hydrogen and the other part of carboxylic acid, like OH group, and over here this OH and other part of N, like amine or H hydrogen, they will tend to react and form. They will form such structure. Here N will be left with a free hand to form a bond, and we will be having CH2 6 We have NH, and we have here C double bond O. Then we have CH2 4 and C double bond O. Okay, and here's the Hanspeak. That means here we can also continue with NH. Like same pattern will be here. Here will be a diamine here, and again NH. Like it continues. Okay, I won't be drawing that much. I'll be just simply. Where did it go? So basically this is our structure and this is our repeating unit. How many times it repeated itself? Now it repeated itself n times. Now there will be this water form, isn't it? I mentioned earlier, because due to this OH and H, water will be formed. Now how many water moles will be formed? So there is a formula. We can just remember that there are actually 2n minus 1 times water. Oh, how is that? Or like how do we define that? See, for between like for 1 mole of each, here is 1 mole water formed, and here we have 1 mole of water being formed. Okay, so that means we can say that if there is just one of each are present, that means 2n times of water could be formed. But think it in this way. Let's say let's say how do I say that? We have here a phenylamine, and here carboxylic acid, they reacted. Another phenylamine is here, another carboxylic acid is here, and they in turn, let's say, react with each other here. So here's this water form, here water form, here water form, 1, 2, 3. Here's this another water being formed, so 4. Then how many total number of water formed? We have n number of phenylamine here and number of carboxylic acid here. That sorry, yeah, the n number. So if that is the case, water is formed twice, 2NH2O. Then why 2n minus 1? I can't actually recall why it was, but that's the case. So once I recall, I will try to let you know. But so far for now, just remember that 2n minus 1 water will be formed. Okay. Okay, that's all for today. Take care.